It appears some pieces of asteroid Vesta ended up on asteroid Bennu, according to observations from NASA's OSIRIS-REx spacecraft. The new result sheds light on the intricate orbital dance of asteroids and on the violent origin of Bennu, which is a rubble pile asteroid that coalesced from the fragments of a massive collision. 6 boulders, ranging in size from 5 to 14 feet, were discovered scattered across Bennu's southern hemisphere near the equator. These boulders are much brighter than the rest of Bennu, with some appearing as much as 10 times brighter than their surroundings. The unusual boulders on Bennu first caught the team's eye in images from the OSIRIS-REx camera suite instrument. The team analyzed the boulders using an onboard spectrometer, which separates light into its component colors. Since elements and compounds have distinct signature patterns of bright and dark across a range of colors, they can be identified using a spectrometer. The signature from the boulders was characteristic of the mineral pyroxene from Vesta and the Vestoids, smaller asteroids that are fragments blasted from Vesta when it sustained significant asteroid impacts. The team tested a few different theories to determine the origin of these boulders. First, it's possible that the boulders were originally part of Bennu, or its parent body. However, this is unlikely based on how pyroxene is created. This mineral typically forms when rocky material melts at high temperature. Bennu is composed of water-bearing minerals, so it wouldn't have experienced very high temperatures in its history. Next, the team considered localized heating, perhaps from an impact. The scale of an impact needed to create large pyroxene boulders is much more significant than what is expected to take place in the main asteroid belt. So the team ruled out these scenarios, and instead considered other pyroxene-rich asteroids that might have implanted this material to Bennu or its parent. This is possible because as asteroids move through the solar system, their orbits can be altered in many ways, including by the pull of gravity from planets and other objects, meteorite impacts, and even the slight pressure from sunlight. The new result helps pin down the complex journey Bennu and other asteroids have traced through the solar system.